Hello there and welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at multiplying polynomials. By the end of this lesson, you should be able to multiply polynomials using the distributive law and the FOIL method. You'll be able to recognize and apply special product formulas. Then finally, you should be able to apply or multiply binomials by trinomials by distributing each term. In the course of the lesson, here are some vocabularies we'll be using, and I advise you pause and quickly take a glance. Without much ado, let's quickly look into the lesson. So let's start by looking at the distributive law. The distributive law is one simple law or method for multiplying polynomials. All the others can be derived from this basic law. Now it says if we have a monomial that is multiplying a bracket, that is b plus c, or that is multiplying a binomial, all we want to do is take whatever you have outside the bracket and then share it. That is what we mean by distribute. So distribute it to each term you have in the bracket. So a multiplies b to give us a b, and then a also multiplies c to give us what? An a c. This is all we are talking about, and it is as simple as you see. The next one will be making use of is what we call the FOIL method. So if you have two binomials multiplying each other, so let's say we have a plus b, and then it is multiplying a b plus, let's say, a c plus d. So we could actually even use our distributive law here. So for the distributive law, it says share. This first term should be shared with what? This whole bracket. And then this second term should also do the same. So even before we go to our FOIL method, we can rewrite this as a, that is the first term multiplying this whole bracket, so that we have into bracket a c plus d. Then our second term should also multiply the bracket, so that we have a positive b into bracket c plus d. So with that, a multiplies c, it multiplies d, and then b multiplies c, and then also multiplies d, so that we have a times c giving us an a c. Then a times d also gives us a d, and then b times c we have a positive b c, and then b times d also gives us what? B d. Using the distributive law once again, this is what we have. But the FOIL method is saying if we don't actually want to write this whole step we have here, then we want to skip and then quickly write our final answer. So it says if you have a plus b, and that is multiplying c plus d, then we should take note of what we have as our first term. So the a here becomes our first term, and the c here also becomes the first term. Now there's also another name we call the outer terms. So this a is also an outer term, and the b is also an outer term. So we have two first terms. That is in terms of using the word first. A is first and c is also first. If you want to use the word outer, a is an outer term, and then d is also an outer term. Then we have the inner terms. So the inner terms are b and then c. And then we finally have the last term. So the last term, if this is the first and this is the first term, then this is the last, and then this is also the last term. So the FOIL method says we should first of all multiply the first terms. So that is a and then c. So let's multiply a by c. And then let's multiply the outer terms. So for the outer terms, we simply mean a and then d. You see? So let's multiply a by d. And then let's multiply the inner terms. So the inner terms we have b and then c. So that is plus B times C, and then finally let's multiply the last terms. So that is B and then D. So B, D. Now, if you look at what we have done, you realize that AC is the same as what we have here. AD is what we have here. BC is what we have here. And then finally, our BD is what we have over here. So what we were able to use the distributive law, we were able to, in a straight line or in a single line, do it also with a for method. These two methods are all fine, and you can take the one that suits you best. If you want to memorize the for method, fine. If you just want to go by simple intuition using the distributive law, that is also fine. For what we have considered so far, they are all binomials. But what if we actually have a trinomial? A trinomial is simply having a three term. So if you have A, so let's say you have an A plus B, that is multiplying C plus D plus E. So you realize that in this particular term, in this particular bracket, we have three terms, whereas this has just two terms. So we apply the distributive law once again. So it says we should distribute each term of the binomial to every term of the trinomials. Then we should combine like terms. So what it means is, in this binomial we have here, let's distribute each term. That is, A should multiply each and every term in this bracket. Then B should also do what? Same. So what we mean is A should multiply C plus D plus E. That is what we have here. So A multiplying everything here. And then B should also multiply C plus D plus E. You see, then now you actually have just a monomial multiplying everything in the bracket. So with that, A comes to multiply C, A comes to multiply D, and then A comes to multiply E. The same applies over here. You see, so simplifying, we have AC plus AD, then plus AE. Then for this as well, we have our A multiplying the B, giving us a BC. Then B multiplying D to give us a BD. And then finally B multiplying E to give us a BE. This is what we have. Just distribute. After all these, we would solve some examples so that you actually have a feel of what I'm talking about. Now, you should always take note that if you are multiplying polynomials and you have variables that are the same, we apply the laws of indices. What do I mean by we do so? We have x raised to the power 2 plus 2. And let's multiply it by x to the power 3 minus 1. So applying the distributive law, this x squared multiplies this whole bracket, and then the 2 also does same. So that we have x squared multiplying x cubed minus 1. And then our positive 2. So positive 2 also multiplies x cubed minus 1. So with that, our x squared multiplies whatever we have here, and then also multiplies our negative 1. 2 multiplies x cubed, then it also multiplies negative 1. So you have x. Since the bases are the same, the laws of indices says when we are looking for a product, we add the exponent. So I have 2 plus 3. Then we now have x squared times negative 1. That gives us a negative x squared. Then 2 times x cubed. That gives us a 2x cubed. Then 2 times negative 1 gives us a negative 2. Simplifying further, we are going to get x to the power 5, x squared plus 2x cubed and minus 2. This here is our answer, but it is appropriate to write it in the standard form. By standard form, I mean you write in decreasing order of the powers. So this becomes our final answer. What I want us to take note here is when multiplying polynomials, the degree of the product equals the sum of the degree of the factors. So these are the factors of what we have over here. And you realize that its degree was simply the sum of the degree of the factors. In as much as we will be trying our best to multiply each and every factors we are being given, there are some that are commonly used, and it is good you get to know, if possible, even memorize them. Now, talking of these special products to memorize, if you have actually gone through our lesson in binomial theorem, then you'll be quite familiar with all of this. For a plus b all squared, that is a plus b all squared, all we are saying is there is no need trying to open up your brackets and all that. You can simply use your Pascal's triangle where you have the coefficient, because the order is 2. So we have 1, 2, and then 1. And then we rearrange our terms. So you have a squared, and it moves in descending order. So a squared, a, then you have a to the power 0 over here, which we don't write. Then in the reverse order, you have b squared, b, and then b to the power 0. And everything is a plus here as well, you see. So these are some of the special ones you can say you would want to memorize, or if you have done binomial theorem, you simply don't need to memorize it. So if you have a minus b all raised to the power 2, you could also use the Pascal's triangle as well. Or you can simply say it is equal to a squared. So a squared, then 2 times a times negative b. That gives us a negative 2ab. Then negative b squared, giving us a plus b squared. You see, if you know all of these up your sleeves, there wouldn't be a need to even say you are memorizing. You can take time to quickly look at these special products, and then let's solve some questions based on all that we have done so far in this lesson. So for our first set of questions, let's look at what we have over here. It says you have to expand. So these are just basic examples that we'll be using the for method and then all that. The first one says we have 2x, so that is a. We have 2x plus 3. Then in another bracket, we have x minus 4. So how do you go about this? You can easily use the distributive or the for method. Let me first of all use the distributive. So for the distributive, we are going to take a 2x to multiply this whole bracket. Then secondly, the 3 also does same. So we have our 2x multiplying x minus 4. And then we have our 3 also multiplying x minus 4. So with this, our 2x multiplies x. 2x times x gives us a 2x squared. Then 2x times negative 4 we have, so 2 times 4. We have a negative 8 with the x. Then 3 times x gives us a 3x. Then we have a 3 times negative 4, that gives us a negative 12. Simplifying further, we have our 2x squared. The negative 8 plus 3 gives us a negative 5x. And then we have our minus 12. This is using the distributive law for even two binomials. If you wanted to use the for method, we have 2x plus 3, and that multiplies x minus 4. So you multiply 2x by x, that gives you your 2x squared. Then you multiply your 2x by negative 4, that gives us a negative 8x. Then you multiply your inner 3 times x. That gives us a 3x. And then our outer 3 times negative 4. That gives us a negative 12. And you see that it is the same as this line we have over here. And you continue to say you have your 2x squared minus 5x minus 12. As simple as that. Then for our second question, the second one says, that is B, x 3x minus 1 all squared. 3x minus 1 all squared. So with that, if you want to use your distributive law or the 4, you can choose to expand first. Anything squared simply means it is multiplying itself. So with that, we have 3x minus 1 multiplying 3x minus 1. So with that, you can simply write your 3x multiplying 3x minus 1. And then your minus 1 also multiplying 3x minus 1. With that, you have your 3x times 3x. That gives us a 9x squared. Then 3x times negative 1 gives us a negative 3x. And then negative 1 times 3x gives us a negative 3x. And then finally, negative 1 times negative 1 gives us a positive 1. If you simplify this, you have your 9x squared. Negative 3 minus 3 gives us a negative 6x. Then plus 1. This is your final answer. But if you look at the special product to memorize we wrote over here, this we have here is in this form. That is a minus b all squared. So if we have 3x minus 1 all squared, in this case, our a would have been what? The 3x. You see? And then our b is simply 1. So using this as our substitution for our substitution, that is a squared minus 2ab plus b squared. Then we are going to write our a squared. This is our a. So we are supposed to square it. Then minus 2 times what we have as our a, which is our 3x. And then what we have as our b, which is the 1. And then the b itself should be squared as well. So that is our 1 squared. Simplifying further, we have 3x squared, which gives us a 9x squared. The negative 2 times 3x times 1 gives us a negative 6x. And then our 1 squared. And you see that this term we have over here, this expression is the same as this expression. So I'm always emphasizing the fact that there are so many ways of solving the math problem. You understand what suits you best and then just follow it with its procedure and you get the same answer. For the last one we have, let's look at how we are going to solve it. As C says, x plus 5, then multiplying x minus 5. For this, let's quickly go directly with the FOIL method. So we have x times x, which gives us x squared. And we have x times negative 5, which gives us a negative 5x. Then 5 times x gives us a positive 5x. And then 5 times negative 5, we have a negative 25. Simplifying, we have our x squared. Then minus 5x plus 5x gives us a 0. So that goes off, and then we have our minus 25. If you are familiar with difference of two squares, then you realize that this is simply x squared minus 5 squared. So this we have here is actually an expansion of the difference of two squares. And looking at the difference of two squares, this is it over here. So if you are to, that is why I was saying it is advisable you'd memorize these special product. If you are to memorize it and you see something like this, you simply know that it is x squared minus 5 squared. So that is it for our first example. Let's take some few more examples. So for our next set of questions here, we want to actually try to look at how to multiply a binomial by a trinomial. So we have to expand. The first one says x plus 2, then into bracket x squared minus 3x plus 4. So let's see how we can answer that. We have x plus 2. Then it is multiplying x squared minus 3x and then plus 4. So it is the same procedure. Each term in this binomial should multiply the bracket. So x should multiply the bracket, 2 should also multiply the bracket, so that we have x multiplying the bracket to give us x into bracket and x squared minus 3x plus 4. Then we have a positive 2, so plus 2 into bracket x squared minus 3x and then plus 4. So with that, you are going to apply your distributive law. With that, we mean x is multiplying each and every term in the bracket. So for the first one, we have x multiplying x squared. And take note, your index, your laws of indices should be applied here. X multiplies x squared to give us an x 2 plus 1, or you can simply write it directly. So x multiplies x squared to give us x cubed. Then x multiplies negative 3x to give us a negative 3x squared. X multiplies the positive 4 to give us a 4x. Then we come to this side as well. So we have 2 multiplying 2x squared. That gives us a 2x squared. Then 2 multiplying a negative 3x. That gives us a negative 2 times 3 is a 6. So 6x. Then 2 also multiplying 4 to give us an 8. After this step, what you do is you group like terms so you can simplify. Grouping like terms, we have our x cubed, then minus 3x squared. That is, this has been written, this has also been written, this is also a squared. So let's bring that here as well, so that we have 2x squared. Then we write those with a power of 1. A positive 4x, that is this here, and then a negative 6x. And then we are left with a constant. This is the only constant term, so plus 8. Simplifying, we have our x to the power 3, negative 3x squared plus 2x squared gives us a negative x squared. Then we come to 4 minus 6, that gives us a negative 2x. And then we have plus 8. It is obvious there's nothing left to simplify. So this becomes our final answer for this question. For the second one, I would advise you pause and then also try on your own to see if you can come up with a solution. If you're able to do that, then well done. Now let's do it together. We have our x minus 1 multiplying x squared plus 2x plus 5. So with that, the x multiplies everything we have in this bracket. So that we say we have our x into bracket x squared plus 2x plus 5. The negative 1 also does the same. So negative 1 into bracket x squared plus 2x then plus 5. So with that, we distribute x over this bracket and distribute negative 1 also over this bracket. X times x squared gives us an x cubed. Then x times 2x gives us a 2x squared. X times 5 gives us a 5x. Then we come to this one, which we have negative 1 times x squared gives us a negative x squared. Negative 1 times 2x gives us a negative 2x. And then negative 1 times 5 gives us a negative 5. So with that, we do our grouping of like terms. X cubed, this is written. Then we go to those of degree 2. So plus 2x squared, that is the squared. And then this as well. Negative x squared. Then we come to that of degree 1. So plus x squared plus 5x then minus 2x, and then our constant term, minus 5. So with that, we have our x to the power 3, then plus the 2x squared minus x squared will be left with just 1x squared. And then 5x minus 2x gives us a negative 3x. And then our minus 5. As simple as that. So with this, I'm sure you can take any binomial and multiply it by a trinomial. Let's look at our last example where we would actually multiply a trinomial by another trinomial. So this is what we have here. And as you can see, we actually have two trinomials. X squared plus 2x plus 1. And it is multiplying x squared minus 2x plus 1. How do you go about it? So we have our x squared plus 2x plus 1. And it is multiplying x squared minus 2x plus 1. So the first thing we need to do is to distribute the brackets to each term. That is to say, 2x raised to the power 2 should multiply the whole bracket, 2x should multiply the whole bracket, and then 1 should also multiply the whole bracket. So that we have x squared taking its turn to give us x squared, then minus 2x plus 1. Then we have our 2x also taking its turn, so plus 2x, x squared minus 2x plus 1. And then finally, the 1 would also do that. So 1 takes x squared minus 2x plus 1. With all of this, we then do our expansion. So x squared multiplies x squared to give us x to the power 4. Remember the laws of indices. When multiplying, we add the exponent. X squared times negative 2x gives us a negative 2x to the power 3. X squared multiplies 1 to give us x squared. 2x multiplies x squared. So we are now on the 2x. So 2x multiplies x squared to give us 2x cubed. Then 2x multiplies negative 2x to also give us a negative 4x squared. 2x multiplies 1 to give us what? A 2x. We come to the 1. So 1 times whatever will give us the same thing. Hence we have x squared minus 2x plus 1. After this, we then group like terms and simplify. So we have x to the power 4. Then let's look at those with cubes. This has been written. For those with cubes, we have negative 2x cubed written. Then positive 2x cubed. That is also written. Then let's look at those with squares. Positive x squared. This is written. Then we have negative 4x squared. This is also gone. Then we have a positive x squared. That is from here. Then look at those with a degree of 1. So with that, we have our positive 2x. This is gone. Negative 2x. This is gone. And then plus 1. Now, looking at it carefully, you realize that some are just the opposite of the other. And by so, I mean, for negative 2x cubed, it goes with negative 2x cubed. Then we have 2x taking out negative 2x. You see, so that makes our simplification much better. Hence, we have our x to the power 4. That is this. And then looking at the squares, we have a 1x squared minus 4x squared. That gives us a negative 3x squared. And then plus an x squared here. So that gives us a negative 2x squared. Then our constant term plus 1. And that is just all. So you realize that if you pay attention to your symbols, the petty things, you don't change a plus to a minus if it is a minus. You don't change a minus to a plus if it is a plus. You see, if you stick to these simple things, you'd always get your answer. This is actually one of the easiest topics, but then what makes it look a little bit some ways because you are writing a lot. So you'd have to pay attention to the minor details. On that note, we want to end this lesson here. Now, in our next lesson, we'll be looking at how to actually divide polynomials. We'll learn how to use the long division, the factor theorem, and then all that. But as usual, I'll leave you with some exercises so you try on your own just to test your understanding. So here you have just 6 questions you can try on your own. They are based on all that we have done so far. This is Have Your Numbers, where we learn maths the easy way. If there's any issue of concern, you can let me know down there at the comment section. If this is your first time on this channel and you think it will be of help to you, you can choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson, where we deal with division of polynomials. You can check the playlist to look at all that we have done before this lesson and after this lesson as well. Do stay safe and bye for now.